Greetings, mathophiles. Welcome to a short video demonstrating the uses of the TI-84 graphing calculator in solving nasty area problems from calculus. The example we're going to use is one that asks us to find the area of the region or regions enclosed by the graphs of y equals 2 sine x and y equals x cubed minus x squared minus 2x plus 1. And those of you who are experienced math folks know that there's no reason to expect that a generic sine wave and a generic cubic are going to be intersecting at any place that's remotely convenient to deal with. And certainly we wouldn't expect to have the chops to find the intersections by hand. Fortunately, we don't have to. So I have on my calculator the two functions entered as y1 and y2 respectively. And I'm going to just start by graphing them in the standard window, -10 to 10 in both directions. And as you can see, there's a little bit of a region that's enclosed by the two graphs there in the third quadrant, and then a somewhat larger region that straddles the first and fourth quadrants in the neighborhood of the origin. And so first thing I'm going to do is get a window that allows us to look at all of this a little bit better. So I feel like that was about -2 to 3 horizontally and maybe about -4 to 2 vertically, just so that we have a little bit better sense for how this looks. And this is something that often happens in these situations. You sort of have to adjust the window once you get your bearings a little bit to get a picture that's a little better for your purposes. And this one seems to be actually now quite good. So we have a couple of options. Option number one is to identify the x coordinates of those two intersection points and integrate from the one to the other the cubic minus the sine wave, because in that region the cubic is above the sine. And then integrate from here to here, which is another location we would have to identify, the sine minus the cubic. But since we're going to be making the calculator do all the work of finding the point of intersection, we might as well make it do the rest of the work as nearly as possible as well. So let's, instead of treating this as two separate regions, let's integrate from one end to the other the absolute value of the difference between these two functions. And let's let the calculator worry about where they're crossing and what's above what when, because it has that capacity. So we really only need to figure out an intersection here, and then the fnInt command will give us the value of the integral. And all we really have to do is be a little bit attentive to issues of potential rounding error, and we're good to go. So I'm going to use the solver to find that leftmost intersection. And I have a video on the use of the solver, so if that's not familiar to you, you might want to check that out. I'll do my best to remember to leave a link in the comments, as the saying goes. So we do need to make an initial estimate, though, and it matters what initial estimates we make because we know that there are three intersections of these curves. We want the one that is to the left of the y-axis. So I'm going to guess maybe -2, just to start the ball rolling. The calculator uses an iterative process, so you have to give it something to start with. And then we'll go alpha solve, and we find that it's about -1.223, and certainly that's going to be the one that we're looking for. So -1.223 is our lower limit of integration. Now, before I get off this and go looking for the other one, there's a thing we need to talk about that has to do with rounding error. Because when I round the limits of integration, I introduce to some, hopefully small degree, rounding error into the final result. And if this is the AP test, for those of you who are students in AP classes, you know that if you get rounding error into the third decimal place, you are in trouble. So what I'm going to do before I move on and find the other location is I'm going to quit out of here, and I'm going to store this number in the memory. I could go off to the side and write it all down. It takes time. It's annoying. I'm maybe going to miss or transpose digits. This is going to be much better. You'll notice that if you've just executed a solve in the solver, that value is stored in the memory as x, and we want to put it somewhere else where it's not going to be overwritten before we need to use it. So I'm going to store it in the memory as a. And the way I'm going to do that, you can't see it, but it's the second bottom up from the bottom left. It says STO for store. I'm going to hit X and then store and then alpha A. And it's going to put it in a place where it's not going to be overwritten by the next time we use the solver. Then we're just going to find the next zero. So math or intersection rather. So math and solver. And I'm going to make a guess. If you remember our graph, something in the neighborhood of 2 was roughly in the neighborhood of our rightmost intersection. So I'm going to hit solve, and it's going to kick out about 2.320, I guess, if I'm rounding to 3 places. So if we integrate from about negative 1.223 to about positive 2.320, the absolute value of the difference between these functions, this should give us the answer to our question. So let's do that. We'll quit out of here. We'll store this as B. So X store alpha B. And then we'll use the fnInt command. So what do we want to integrate? We want to integrate the absolute value of y1 minus y2, or y2 minus y1, doesn't matter. And so the absolute value is the math button, the second menu, the num menu, very first choice, ABS for absolute value. And then we need to tell it y1 minus y2. So that's vars, yvars, function, y1, paste it into our command, and then minus. Go again, vars, yvars, function, click down to y2. Got to close the absolute value command, and then it's comma, x, comma, left limit and right limit of integration. So A, comma, and then B using the alpha command. Hit enter. It's got to think, and I think most of the thinking it's doing is about where the functions are crossing. It's mostly handling the absolute value that's taking the time. But here is our result. It's about 8.672. If you like to go to the standard AP exam 3 decimal places. So that's the deal. You get your points of intersection or your limits of integration, whichever ones you need, using the solver. You store them in memory in order to minimize rounding error. And then you just use the fnInt command to evaluate the integral. Hope this has been useful. Happy mathing.